What does validation mean for model-based definition and related initiatives? Let's talk about that now. All right, validation for model-based enterprise initiatives, what's involved there? Fundamentally, the idea here is that you're going to be taking a model-based definition, which is your 3D model plus GD&T annotations, a lot of non-geometric information, and you will very likely be exporting that into another format so that other people, whether it's in the supply chain, maybe downstream consumers, are going to be using that in their processes. And during that conversion process, the reality is that different software applications use different levels of fidelity to define geometry. And as you convert from one level of fidelity to another, well, things might change in a very small way, but they might change. So the idea of validation is that you can check the original design against derivative definitions and that they are the same. And that's really important when you think about today. A lot of tooling is designed directly off of the 3D model. So small changes there can actually affect your tooling, which in turn will affect the parts that you manufacture using that tooling. So that can actually end up increasing non-conformances if you have something that is changing a little bit and doesn't match within the tolerances that you've defined. Now, what's really interesting about this is that if you think about the 2D drawing approach, this really wasn't as much an issue. And the reason why that is in a component drawing, you have your three views in an isometric typically, or maybe a close-up or cutout type of view. The idea then was that you dimension everything to geometrically locate everything. So people would look at those dimensions and kind of traverse them to get out to a point maybe further out on the end of the component. So really, even if there were small changes in the lengths of the 2D entities, it didn't matter because they're dimensioned anyway. But in reduced annotation initiatives, this is where you, whether it's with a 2D drawing or with a 3D model, you rely more on the inherent definition of the geometry instead of dimensioning everything out. And as a result, engineers are having to do less work documenting their designs. They can rely basically on the definition of the geometry instead. As people migrate to that, whether it's with a 2D drawing or with a 3D model with a model-based definition, you still have this validation issue in both cases. Because with a 2D drawing, a lot of cases, whether you're going out to DXF or a DWG or a JPEG or another type of additional format for the drawing, you still need to validate that the length of an entity is the same as it was in the original. Additionally, the same thing we talked about before with the 3D model, when you go from the original 3D model to other versions, whether it's JT or 3D PDF, you got to make sure that it agrees with what you originally designed. That is the fundamental issue that validation in model-based enterprise initiatives is trying to address. Trying to make sure that these things match so that when you do get to the end of product development, you start getting parts back. You don't have a whole bunch of non-conformances. You don't have a whole bunch of false positives with quality and inspection and all the other downstream applications that you have for model-based definitions. That's it. Take care and talk soon.